We are working on enhancing the Sports Heroes project from the YByte Python curriculum available at www.ybyte.in. One of the things that we do, which is quite interesting in my opinion, and brings out the value of using set operations, is this comparative analysis, where we look at things like, who are the players who have won, let's say, either Wimbledon or French Open, or both, let's say, or only one but not both, and so on. So this is what we call comparative analysis. This definitely gives us interesting insights, and like I said, it tells us the value of using set operations. And as we saw, these are quite important in mathematics, and in fact, these kind of problems keep coming up in a lot of day-to-day scenarios as well. Now it's quite tempting, to, let's say, extend this project and say that, okay, look, I will, for example, add to this mix, say US Open or say Australian Open or perhaps both. When we do that, obviously it's possible to analyze those tournaments. We would also want to expand our comparative analysis in that direction. However, as you can see, the way this code works is using set operations, so or say union, intersection, and so on. And you can clearly see that if I want to expand this, the number of possibilities just keep going up and up. So while it's manageable, let's say for 3 sets or even 4 sets, ideally we would like to, do it in a way that any number of sets could be taken into this function and we can be given the result. So of course, that's a little bit more general, but that's also a good programming practice. So in this video, we'll see how we can make this happen. And then from subsequent videos, we'll start to build those features. Uh, Basically, let's look at comparative analysis once again. The idea is that we are looking at 2 sets which have some overlap. So for example, I can figure out who are the people who have won both. That's this purple region here. And then there is individual. So only Wimbledon, not French Open, only French Open, not Wimbledon. Let's say we go to 3 sets. Well, the principles remain the same, but the possibilities increase. For example, now I have this purple region, I have a green region, I have an orange region, depending on which 2 tournaments I'm looking at and excluding the third one. However, there is clearly this one overlap of all that we call all. That is the intersection of all the tournaments, which is people who have won Wimbledon, French Open, and US Open, for example, right? If I look at 4 sets, well, the possibilities go even further. But then clearly I have these sets, which are, for example, in this case, this light yellow, this blue, this orange, this brown, which tells me, for example, only Wimbledon, only French Open, only US Open, only Australian Open, and so on. And then there is a single intersection of all of these, which I call all. Clearly, the number of possibilities you can see has multiplied a lot because different combinations can be seen for different purposes. However, we can still make some general results that yes, the possibilities keep multiplying, but clearly there is exactly one and one union, right? One and exactly one union. These are the people who have won at least one tournament. And then likewise, there's exactly one intersection. And then there is exactly n sets that capture the winner of only one tournament, not others. So what do I mean by this? For example, in this case, only one is this yellow, blue, orange, and brown. Um, in this case, gray, yellow, and blue, and so on. So there's only like when we have 2 sets, there are 2 sets. Let's say when you have two, let's say comparing two tournaments, we had 1 set here, 1 set here. 3, we had 1, 2, and 3. 4, we have 1, 2, 3, 4. So in general, if I give n sets for this thing to analyze, I will get n out of this, which capture only one tournament winner and not others. And finally, there's exactly one, those who have won exactly, those who have won at least one tournament, but not all. And that can be seen. That's kind of like the generalization of symmetric difference. We are looking at this union, this. In fact, this union will give us everything except, let's say, this portion here. And likewise, right? So, yes, there are multiple possibilities, but we can, this 4, let's say, statements capture pretty much what we have been doing. And hence we can create a general function which will take any number of sets. Notice I'm giving a variable number of arguments. So star winner sets. Now what this means is that I'm going to pass into this any number of sets. Inside this function, it will become like a tuple of sets. And then we can analyze, for example, union, intersection, only one, and so on. So we will go ahead and build this one by one. Like I said, if you're doing, for example, 3 sets, you could have done this without this as well. But this is general. Once we have this, it actually becomes quite nice to, use this function again and again. So we'll come back in the next video and start building this function, starting with the union function. I hope this was interesting to you. In general, building activities, thinking about how to enhance them, managing their complexity and implementing those enhancements is a great way to learn Python programming, just like what we do at YByte. Look at our website, www.ybyte.in, because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.